Suppose Ken plans on contributing $8,000 every year to his tax-free savings account. What's the future value after 20 years if his money can earn 4.25% compounded annually? Since we have a recurring payment going into this savings account of $8,000 every year, this is going to be an annuity. We also know that the payment structure of every year coincides with the interest rate being compounded annually. So this is a simple annuity as well. Let's assume that the $8,000 payments happen at the end of every year so that we have an ordinary and simple type of annuity. So this future value formula should apply for this specific problem. Let's start filling in some values into our formula. Here, we know that the periodic payment size is $8,000. Next, we look towards trying to fill in a value for I. We have 4.25% compounded annually. Our frequency number is 1, so it's just 0.0425 that's needed here. The last thing we need is the number of equal-sized payments. Since these payments happen every year for 20 years, we should actually have 20 of these equal-sized payments. Our last step is trying to get this into the calculator to get a final future value. Let's begin inside the numerator of the bracketed fraction expression. So we're going to go open bracket 1 plus 0.0425. We're going to close that bracket and raise this to the power of 20 and then subtract 1. I'm going to hit the equal sign here. This is the decimal number that represents the numerator of our fraction. We need to divide this by 0.0425. And then we need to take this number, which is actually the number inside of our square brackets, and then multiply it by the payment size of 8,000. This gives us a future value of $244,500.01.